Okay, we're just going to practice some more examples here. So if you want to write 4, 5, and 6 down and then pause it and attempt to work them on your own, and you can check your answer. Okay, so since this is a right hand limit, let's just look at it for a second to see if I direct substituted just 1. If I had 1 minus 1, I'm going to have some number close to 0 in the denominator and some number close to what in the numerator if we put a 1 there. So we're thinking we're going to have some number that's going to be close to 3. So this is just my notation. It's not the exact value. And I'm going to have, but it's going to be a positive number. So I'm just going to have a positive number in the numerator, and then I'm going to have something close to 0 in the denominator, but let's go to the right of 1. Will it be a positive value or a negative value? Negative, yes. So a number divided by 0 is going to give us infinity, okay? But what's a positive divided by a negative? A negative, so when we get negative infinity, we just know that this does not exist because it's unbounded there. Okay, so let's look at number 5. This is just the limit of our function here as x approaches 4. Okay, well we can just attempt what? Direct substitution, yeah. We can attempt direct substitution here. So just substitute the value for 4 and solve that. So we'll just get 1/2 here. Okay, and number 6, we're going to have the limit of f of x as x approaches 1. Plug in a 1 there, and we're going to get some values. So we can go ahead and direct substitute for this one as well. So we'll just have 1 cubed minus 1, and then 1 squared plus 1 plus 1. In the numerator, we'll just get 0. In the denominator, we get 3. So what's a 0 divided by a number? Just 0. Good. Okay. We're going to limit of x squared minus 2x over x cubed as x approaches 0 from the left. This is going to be a left-hand limit, but before I start, what do we even notice about this? It could be factored. Usually if you do see opportunity to factor and you can factor out, sometimes it makes it a little bit easier for you to determine. So I'm going to go ahead and take the extra step to factor here. Okay, and then after that we can see that an x is going to simplify to, we will have x minus 2 over x squared as x approaches 0 from the left. Now I want you to pause it and to evaluate this and see what you come up with. Okay, so we can kind of throw out, let's just do negative 0.1. If you have a negative number and you subtract the negative number, what are we guaranteed to have? A negative number. Okay, and then down here we know that we're going to have something that's very close to 0, but what's a negative number squared going to give us? A number that's really close to 0, but it's positive. So we're just going to have a number divided by 0 is infinity, and then a negative divided by a positive is a negative infinity, which does not exist. Okay, try direct substitution. If I plug 0 in, I will get a number in the numerator and a number in the denominator. So basically, I'll be able to use direct substitution here. Okay. Limit of x squared minus 16 over x plus 4 as x approaches 4. And this one we can do direct substitution. We would get 4 squared minus, which is 16. 16 minus 16 is just 0. 8 there, so we just have 0. Okay, let's look at this problem. Attempt direct substitution, I will get 0. So first of all, we can see this can factor too. Let's go ahead and factor. Okay, so when we simplify our factors there, we're just going to get this. Now, if we substitute there, you're just going to have some number, which in this case is particular number 1. If you get a number over 0, that gives us infinity, and then it's going to be positive, positive, so you have infinity, which is does not exist. Now, okay, so now let's move to limits at infinity. Limit, we're given this function. Of course, we could probably check to see if that's factored, but first of all, if I just direct substitute it, infinity squared is just infinity minus infinity. We just would have something that's infinity over infinity, which is in likeness to our indeterminate form of 0 over 0. And basically that just means more work needs to be done. Okay. One of the methods that we're going to use is to divide the highest power of x, but usually we use to try to use the highest power in the denominator. That typically gives us the easier solution. And then we'll reduce the fractions and then substitute to see what we get. So what is the highest power of x in the denominator in this term? X to the third power. Okay, so I'm going to show this, and we're going to write these out. We'll say, you'll need some room here. So the first term is x squared, and so I'm going to divide it by x cubed. Actually, let me do it this way. X squared minus x plus 3. And then so if I divide everything by the highest power in the denominator, divide everything by x cubed. Okay, then I write my denominator down, which is 2x cubed plus 1. And in likeness, I divide every term by the highest power of x in our denominator. Okay, so that's the representation of it all. This. Okay, so the next we're just going to simplify term for term for term. Let's limit as we're going to look at this as it approaches infinity. And what's the first term going to simplify to? 1 over x. Good, so I just have 1 over x minus, what's the next one? 1 over x squared plus 3 over x cubed. Okay, that's my numerator. Now let's do the same thing in the denominator. I'm going to be left with just 2 plus 1 over x cubed. At this point we can see we actually have a value here, which is good, but we're going to substitute in infinity. So we're going to substitute in, that's going to be 1 over infinity minus 1 over infinity squared, which is just infinity, plus 3 over infinity cubed, that's just going to be infinity. In the denominator we have 2 plus 1 over infinity cubed, which is just infinity. Now let's go back and what is a number divided by infinity? Yes, 0. Good. A number divided by infinity here is 0 and 0. Any number divided by infinity, 0. So then in the denominator we have a 2 plus 0. So basically we just have 0 divided by 2, which is 0.